if we don't have a 90-degree angle, then I've always told you you couldn't use your trig function. Now, that's partway true. We can't use them with the basic definitions that we've had, but there is what's called a law of sines and a law of cosines that apply to any triangle. So when I say oblique triangle here, I'm just meaning it's not a right triangle. It's any other triangle that we may have. So that is the first thing, just that definition. If I say oblique, it's not a right triangle. The second part you don't necessarily have to write down. That's what we're going to be talking about. But we can always find all three sides and angles if we know at least one side and two other pieces of information, whether that be all three sides, two sides and an angle, one side and two angles. We can get the rest of the information we need. So really all you need to write down on this side is the definition for oblique triangle. And I'm going to give you the law of sines. You're going to write that down. This I will give you on quizzes. We won't have a test over this stuff, but on the quiz over this stuff I will give you this. Sometimes the ACT does law of sines questions. They always put the formula in the question and just ask that you use it. So you wouldn't have to memorize this, we just have to be able to apply it. So, in any triangle, doesn't have to be right, these three things are all equal. The ratio of the side over the sine of the angle. So A over sine A, B over sine B, C over sine B. C. We use lowercase letters for sides, uppercase letters for angles. So you want to write that down, put a big star next to it, highlight it. So solve triangle ABC. That means find all the angles and all the sides. If angle A is 32.0 degrees, angle C is 81.8 degrees, and side A is 42.9 centimeters. So reviewing for the final, how many significant digits are in this problem? Hmm? 3. Since there's a decimal, you count the 0. So there are 3 significant digits in the problem, so we should answer with 3 significant digits if I actually do that. Okay. You'll notice that for A, I know both the angle and the side. The other piece of information I have is for, my picture is wrong. I labeled it as B in my picture and I called it C over here. Which one do you guys want to make it? My picture, my wall. Just make this angle C. We'll find it. Okay, and remember your side is across from your angle. Okay. If I wanted to find side C, we need 3 pieces of information still. We need side B, we need side C, and I also need angle B, correct? What's the easiest to find out of all those? Angle B, how are we going to get that? So if you did 180 minus 81.8 minus 32, angle B is 66.2 degrees. Okay. Now let's start finding some sides. What you can do is take the law of sines and take 2 ratios at a time and set them equal. So if I wanted side C, for instance, we know stuff about A, so we could say A over sine A equals C over sine C. And then plug in the stuff you know. Side A is 42.9 over sine angle A is 32 degrees equals side C I don't know over the sine of 81.8 degrees. What mode should we put our calculators in? Degrees. So go ahead and do that. Then how would I solve for C? Multiply it over. So you just type this all in. 42.9 divided by the sine of 32 times the sine of 81.8. And if I'm answering with 3 significant digits, I get that side C is 80.1 centimeters. Make sure when you hit sign 32, you close your parenthesis afterwards. So every time you do a trig function, it opens a parenthesis. Make sure you're closing that. Is that one okay? We also need to find B. You can't anymore. A lot of times when we had 2 sides, we do Pythagorean theorem to get the third. Why can't I do that? It's not a right triangle. But I can do the law of sines. You take any 2, so I could say A over sine A equals B over sine B. So A, 42.9 over the sine of 32 equals, I don't know B, over the sine of 66.2. And I get that side B, 74.1 centimeters. That's it. That's the law of sines. We have any questions on that? Okay, good.
Is it okay if I write like, oh my god, there's angle B? Like,
Yeah, that's fine. Fits me. Anyone else not get it? It should be in degrees.
We're like always have to get on there with all these stuff for numbers and stuff because we don't put the wrong things.
Any other questions there? What's, do we need another problem exactly like this? Okay with that one? And just as a word of warning, whenever possible, use the values that were given in the problem. You know, I used my A and my sine A in both of those just so that if you made a mistake in calculating one value, you don't miss everything after that. So if you can, use the numbers they gave you. Okay, Kurt Samuels wishes to measure the distance across the river. He determines that angle C is 112.90 degrees. How many significant digits is that, guys?
4.
Okay. And angle A is 31.10 degrees, and side B is 347.6 feet. So we're doing 4 significant digits on this one. Find the distance across the river. Now, in my picture, if this is angle C, then the distance across the river, that would be, or this distance here would be C. The distance across the river that we're looking for is side A, right? Just from the way this triangle is set up. So I know that I have to use in my formula, the A over sine A, because I need to find A. And I could use any of the other two pieces. Which side do I know? So we would have to use the B one. Do I know angle B? How can we get it? So 180 minus 112.9 minus the 31.1. So angle B is 36 degrees. So now we just set this up. So we have A over the sine of 31.10 equals B, 347.6 over the sine of B. So we're going to multiply our sine over and just plug that in our calculator. What do you get? And 5.5 feet across the Is that okay? I would like to do maybe one more example, and then if you've got it, I'll let you work on that one. Hmm. Oh, come on, I always thought hers were fine.
Say almost every single one really quick.
Two ranger stations are on an east-west line 110 miles apart. How many significant digits is 110? 2. Since there's no decimal, we don't count that 2 wrong yet. A forest fire is located on a bearing. Ooh, oh, I can do that. North 42 degrees east from the western station at A, and a bearing of north 15 degrees east from the eastern station at B. To the nearest 10 miles, how far is it the fire from the western station? Can you give you a second to draw your picture before I start talking? Okay. We need the actual angles in our triangle. This 42 degrees, remember when we measured bearing, it went from the north-south line to the side, so that's not in my triangle. But you know that AB is an east-west line. An east-west and a north-south make what kind of angle? 90. So to find this, you just subtract from 90, so this angle is 48 degrees. Okay, how am I going to find the angle over here for B? We'd have to do 90 plus 15, because this one is bigger than 90. Right, the 15 is the distance from the angle to the north-south line, and we know the north-south line down would be 90. So this one is 105 degrees. So then you could get angle C if you did 180 minus 105 minus 48. Okay, we've got all of our angles. Which side am I looking for? B. So I have to use the B. Which side do I know? C. So we would have to do B over sine B equals C over sine C. So we don't know side B over the sine of 105 degrees equals side C is 110 over the sine angle C is 27 degrees. So to get B by itself, you are going to multiply over your sine 105. And, right, this comes out to be 234, but two significant digits would call it 230 miles. I'm assigning odds, so you can check your answers in the back and let me know if you get some.